Hello everyone, welcome to this session. In this session, we will talk about matrix. So what does MATLAB stand for? Matrix Laboratory. MATLAB has been optimized to work well with matrices. In this session, we start from introducing how to enter a matrix. First, let's see what is a matrix. So matrices are variables that they are used to store multiple values together in a single variable. According to dimensions, we have a one-dimensional matrix. In this case, we often call it a vector or array. When it's two-dimensional, we call it matrix. One is more than two, it's n-dimensional, we call it tensors. There are a couple of ways to enter matrix in MATLAB. For example, through manual entry, and we can use built-in functions, or we can load a matrix from an external file. I think for the third one, you have already seen it in the previous sessions. So in this session, we mainly talk about the manual entry and use built-in functions. Let's see the manual entry. When you enter a matrix into MATLAB, you need to create the matrix, use square brackets. Inside the square brackets, when you want the element in the same row, we use a comma to separate them. When you want to start a new row, we use a semicolon to start a new row. So let's see an example. Square brackets, inside the square brackets, 1, 2, 3, semicolon, 7, 8, 9. So let's see this comment. So we use square brackets means what? Means we are defining a matrix. So 1, 2, 3 means we are defining the first row because it's comma here, and with a semicolon here, we go to the second row, 7, 8, 9. So we can see here is a 2 by 3 matrix, 2 rows, 3 columns. You can see it. So semicolon here, change another row. This is a manual entry, and you can enter any matrix using this way. So here we can see this is a ANS. So what is ANS? Right, so ANS is a last output, but I did not assign it to a certain variable. So then it uses ANS, the variable ANS here. So normally in real world, for any matrix we defined, we will assign it to a certain variable. So for example, A equals to this matrix. And for some particular functions, MATLAB has built-in functions. For example, the zero matrix. So we can say this is here, zeros, n, comma, n. So we can see this is a record the last session using a function. The function name, parentheses, arguments. So the function name, we call it zeros. The input are m and n. So what this function is doing, we generate a matrix of m rows and n columns, and all the elements is 0. So let's see an example. M equals to 3, n equals to 5. We can see zeros, 3, 5. So this one generates a 3 by 5 matrix composed of all 0. 3 rows, 5 columns. Similarly, we can use the ones function. Ones, parentheses, mn. As you may guess, this generates the n by n matrix, but the elements are not 0, this time is 1. So the example, m equals to 2, n equals to 7. So 1s to 7, we generate 2 rows and 7 columns. This matrix of 1. We can also generate random numbers. We can use a function called rand mn. So this will generate an n by n matrix. So what are the contents? These are the uniformly distributed random floating point numbers between 0 and 1. So they are random numbers between 0 and 1, and they are uniformly distributed. So the example is here. So a 3 by 6 matrix, 3 row, 6 column matrix, all of them are the uniformly distributed random numbers. Another one, the I function. So I function, we generate, we call it the identity matrix. So this is 1 in linear algebra. So if you don't know this, that's no problem. So we can generally describe it. So the identity matrix means only the main diagonal of the matrix is 1, while all other places is 0. So square matrix means row and column are the same. So we can, that's why we only have I, M, not I, M, n. So we can see I4. So this generates a 4 by 4 matrix, and the main diagonal is 1. Right. So more details, you can see the live script. Then we have another function. We call it linspace. This function is quite useful to generate the linearly spaced matrix of n elements between x1 and x2. So we can say linspace with a parenthesis x1, x2, n. So this means I generate the starting point is x1, the end point is x2, and there are n points, elements inside this matrix. So let's see an example. x1 equals to 0, x2 equals to 2, n equals to 11. So linspace 0, 2, 11. So this means I generated 11 elements starting from 0 here and end at 2 here. So the total number is 11. And these 11 elements are equally spaced. So we can see the step size here is 0.2. An alternative way, we can use a colon operator. So we can see the example is here. 0, 0.2, 2. So this means I start from 0, I end at 2. 0.2 is the step size. So still this. We can see using linspace or using colon, we generate the same thing. Right. So remember these two methods. Later it will be useful when you do a loop or you are doing a group of variables with equal space. Right. So that's all for this session. At the end of this session, I put the functions we have described in this session here, and these are hyperlinks, and you can see that how to use them, link to their help files. So that's all for this session. Thank you very much.